I've been asked to have a look at this job because the customer has an interesting scenario. He's got power in the garage, he's got power in the kitchen. They're on two separate circuit breakers, but what happens is when he plugs an item in, one of those circuit breakers trips. Now they're RCDs, and even though he trips a circuit with the breaker, the power doesn't seem to go off. And if you put an RCD tester into one of those circuits, it doesn't trip at all, neither of the circuits. So what the fuck? Let's have a look at what's going on. It's these two circuits here. We've got a kitchen and a basement. As you can see, they're both currently tripped. So we'll go and we'll turn them both on and have a look at what's happening. So we have power in the basement, and we have power in the kitchen. Beautiful. So we'll try out the RCD tester, and it doesn't appear to trip. Here's another way of testing, tripping an RCD. We'll just go from active to earth, and we don't seem to have any power. Does that mean we didn't have an earth? Well, we don't appear to have any power. So I'm pretty sure that that's tripped. As you can see, we managed to trip two breakers with a set of test lamps. That's a pretty good sign to me that the circuits are interconnected. In other words, we've got two circuit breakers on the same circuit. Alright, let's have another look. So I've checked that the power's off, and we're going to measure the resistance between active and neutral. As you can see, it's 11 ohms. Now that 11 ohms is just because I haven't unplugged any of the customer's equipment. Something's plugged in, got 11 ohms. I'm not measuring anything. It's okay to leave the customer's gear in, saves me the heartache of unplugging things. So I'm using the customer's equipment as a resistor. So everything on that circuit should have 11 ohms across it. And once again we have 11 ohms. Okay, so we're checking the kitchen again. And we've got, it's 10 ohms, 11. It's pretty much the same thing. So, to my way of thinking, it's highly unlikely that the basement has got exactly the same resistance on it as the kitchen does. So I'm pretty sure those two circuits are on the same circuit. Let's have a look at what happens if we turn on one RCD. So we've switched on the kitchen. Do we have power in the basement? Yes, we do. Do we have power in the kitchen? Yes, we do. Now that we've established that they're both on the same circuit, does the RCD tester work? Works beautifully. So what's happening here? Just to make it all nice and simple, I've just drawn a load instead of an outlet. I've got a main switch up here. I've got an RCD combo with its toroid and trip coil. I've got another RCD combo with its toroid and trip coil. Trip coil. Now, when the two, so this is how the circuit should be set up, but what's actually going on is there's a connection between here and here and here and here, which means that it doesn't matter whether you measure the resistance here, you get the resistance of this one in parallel with this one always, or whether you measured it up here, it would make absolutely no difference. You would get the same result. So when we used the test lamps to trip the RCD, we went from an active conductor down to earth. And there was a reasonable amount of current, enough to trip both RCDs, so they both went off. when I use the RCD tester, all the RCD tester does is puts in a very small resistance in here, down to earth, and it only draws enough to trip the RCD, 30 milliamps. So it's about 10,000 ohms or something. So if we use an RCD tester, some of the current is coming from here and some of the current is coming from here. Let's suppose it's balanced and we get 15 milliamps from here, 15 milliamps from here. There's not enough to trip either of the RCDs, which explains why the RCD tester did not trip our RCDs, but the test lamp did. So we've now solved the problem by simply disconnecting one of the RCDs. Now our two circuits are one circuit protected by one RCD. Problem solved. It just means that the poor customer has got the basement outlets on the same circuit as the kitchen. This is the current short-term solution. The electrician who's doing the job may decide to adjust that later on, but there is definitely an interconnection between these two circuits. We saw that because they both had 11 ohms no matter where we measured it on either circuit.